I'm Anil Kumar. In this video, we'll practice for the test on rational functions. It is level 1, question number 2. The question is, state asymptotes, domain and range for the given functions. We have two functions here for practice. First one is y equals to 1 over x squared minus 4x minus 12. The other one is y equals to 2x minus 7 divided by 7x plus 2. You can always pause the video, answer the question, and then look into my suggestion. Now, to find the asymptotes, we need to factor the denominator. Whenever you're trying to analyze rational functions, first step should be factor denominator at least, right? So here we have 1 in the numerator, and the denominator is x squared minus 4x minus 12. We are looking for product of minus 12, sum of minus 4. So it could be factored as x minus 6 times x plus 2, right? So that becomes the factored form. Now we can easily write what the asymptotes are. Asymptotes are at x equals to 6 and x equals to minus 2, right? So we get from here asymptotes which are at x equals to 6 and at x equals to minus 2. We can also write the domain of the function, and we can say domain of the function, let's say in short I'm writing everything, is x belongs to real numbers. And what will it not have? It will not have these 2 points, clear? So it will not have these 2 points, so x is not equal to 6 or minus 2, right? However, the tricky part is the range. For finding the range, we need to analyze this function further. I prefer to sketch these functions quickly to find the range, right? So let me show you the sketch which we should or we can go for. It will not take long time. I mean, what we will do here is that we'll sketch the parabola x squared minus 4x minus 12, which is x minus 6 times x plus 2. That means we're talking about two zeros which are at 6 and minus 2. So, and this parabola opens upwards. So we can say that the parabola is kind of like this, right? So that's the kind of parabola. As we identified vertical asymptotes which are here now, this is at minus 2, this is at plus 6. Minded, this is review, so I'm assuming that you know most of the concepts. There are other videos which will explain you all this in details. Now, whenever you have this kind of a function, you know the reciprocal of a parabola will be a 3-piece function, correct? So if you sketch the function itself, function will be reciprocal of the positive part is positive. Somewhere here will be 1, so that will be an invariant point. So it'll be kind of like this, right? So that is kind of the function here. As far as the bottom part is concerned, it will be kind of like this. So wherever the value is 1, which I'm not calculating, but what we are really interested in this particular case is we need to find range, right? We need to find the minimum of this, because when this gets reflected, I mean 1 over that is what we are looking for, correct? So the part here we are really interested in is this part, right? Because the curve will be kind of like this. Don't think that this is like cutting here, right? I'm not calculating what is the value of this function at x equals to 0 for the time being. We know it is minus 1 over 12, and this is, I'm not saying this is overlapping, okay? Okay, so we are really interested in, oh my god, so okay, anyway, this is a smooth curve, right? This is a smooth curve, kind of like this. The negative part will be moving downwards, but we are really interested in this value, since that affects the range for us. And this value is reciprocal of that. We know for this parabola, maximum will be at midway, right? Between these two, that is at x equals to 6 minus 2, I mean add them, divide by 2, which is 4, correct? So at 4, that is the value. if I write 4 here, I get 4 minus 6. So let me write down the value 4 here to calculate the value of y. So what we can do is we can say y equals to 1 over, if I write 4 here, 4 minus 6 times 4 plus 2, I'm sorry, 6 minus this is 4, and this is actually 2, not 4. I'm sorry, this is 2. So this should be 2. So 2. Okay, 2. Right. So y is equals to, the midway is this point, center point, or the axis. Let me write now. Axis is equals to average of these two roots, which are 6 plus minus 2 divided by 2, which is 4 divided by 2, which is 2, right? So we'll substitute 2 here. So 1 over 2 minus 6 times 2 plus 2, which is 4 times 4 with negative sign, minus 1 over 16. So this point is minus 1 over 16. You get the idea. And that gives you the range. That gives you the range. So range is not so easy to find. You have to do that calculation for such a curve. And now you can write down the range. And okay, let me squeeze in the range here. So we have range for this function as y belongs to real numbers, where now since the degree of the denominator is higher, we do have a horizontal asymptote, right? So which we are not asking for here, but we know this function approaches 0, but it is never at 0. So you know that y is not equal to 0. That is one part. The other part is y is greater than, y is not equal to 0, and y is actually, you can say y is, we could actually say y is not in between these two. So where y is, we can say, greater than 0 and y is less than equal to minus 1 over 16. You could write like this. That's better. So the range is either greater than 0 or less than equal to minus 1 over 16 for this particular function. So if you have range also to be answered, it could be a bit tricky. You need to calculate the local maximum here to really get the correct answer. I hope that concept is clear, right? For this question, it is simpler. This is more or less like 1 over x function. Now here, let's answer the asymptote part. Well, denominator, 4x plus 2 equals to 0, just equate to 0, and that gives you x equals to minus 2 over 7, right? So we can write down that the asymptote is x equals to minus 2 over 7. The domain for the function here in this case is x belongs to real numbers, but x is not equal to minus 2 over 7, right? Now, how to get the range? Now, in this case, we have a horizontal asymptote. Since the degrees are same, the function really approaches 2 over 7, which is y equals to 2 over 7. So the function is never 2 over 7. So that part is not in the range, rest all is. So we can say that range for this function is y belongs to real numbers, where y is not equal to 2 over 7. Is it okay? So for such a function, you could write range very easily, kind of like this. Some of you, if you want to really sketch it, you could also do it. Well, the vertical asymptote minus 2 over 7, just do that. We are making a very approximate sketch here. Horizontal asymptote is 2 over 7, right? This part, this ratio, 2 over 7, which is positive, so I'm just doing it on this side. If you substitute x equals to 0, you get minus 7 over 2, some negative number, that's what I'm trying to say. And the x-intercept is when numerator is 0, which is 7 over 2, somewhere there, right? So that kind of gives you the diagram. So you could say that this is kind of like this. Is it okay? Kind of like this. Where this point here, you may be required to sketch such functions, and that is why I'm extending this, right? So So y is 0, that means the numerator is 0, which will be 0 at 7 over 2. When x is 0, we get minus. This point here is minus. When x is 0, it is minus 7 over 2. Okay, minus 7 over 2. Right. And that is how the function will look. We have a horizontal asymptote and vertical asymptote as described here, and that gives you range of the function as all real numbers except 2 over 7. I'm Anil Kumar, and I hope that gives you a good practice for your own test. Thank you, and all the best.